Hey guys, welcome back. This is our third and final Linux tutorial. Um, and one thing that I want you guys to keep in mind is that all these tutorials are just demonstrations of the basics, right? So I'm not really going through all the details and all the arguments of the commands and all the possible ways they can be used. The goal of these guides is just to get you guys familiar enough with Linux just to be dangerous, right? So I hope that you will spend some time after these lessons and research some of these commands on your own. Maybe even download a Linux distribution and install it on one of your home computers, or get one of those live CDs and just boot up and just play with it. I mean, you never know when this knowledge will come in handy, so it will behoove you to spend a little bit of time and familiarize yourself with these commands. The commands that we went over have other arguments that are very useful, and there are many other tools that you would use in your daily life if you were a Linux administrator. So as always, on the right we have a lesson plan. We have a commands that we will go through. Uh, Not that many. Today's lesson will focus on how to interact with different files, and I also included several commands that would be good next steps for you to learn. Now, awk and sed are a little bit hairy, but they're very powerful commands, and they will definitely make your life easier if you're stuck in a Linux terminal all day. Alright, so let's go ahead and get started. The first command is echo. Echo command is very basic, it's just like pwd. Echo will just print output to the screen. In the Linux world, we'll say standard output, which usually means the screen, but it can also go into different files. Alright, so the next command is nano. Nano is a text editor that is very, very easy to use. So if you can imagine, in Windows, you would have Notepad or WordPad, and each text editor has many different options, right? And you can click on File and Edit, and that same functionality is hard to replicate in the terminal. And I think Nano did a really good job of making a text editor that's very simple to use. So I can create a new text file, nanotest.txt. If the file does not exist, it will create it. If it does exist, it will use whatever is existing. Boom. Now we're in Nano. We can add some content. This is the second line. And you can see that on the bottom, you have several options of what you can do with a file. The caret sign is a shortcut for control, right? So for example, now that I'm finished editing this file, I can control and X at the same time, and that equates to exit. And now it prompts me, it says, do you want to save this file? So I will press Y for yes, and then it confirms the name of the file. So I can just hit enter, and now when I do an LSL, I can see that I have a new test.txt file. I can also cat it and verify that the input, everything I put into it is actually in there. So pretty straightforward. There's another text editor called VI. So if you find yourself in a system that does not have Nano, you will be stuck with something like VI. And VI is a very powerful text editor. It's a bit out of scope for this tutorial, but if you do decide to go the Linux route, I highly recommend that you get really familiar with VI. Alright, so the next command is less and more. Basically what happens is, if you have a really large file, you cannot print it all to the screen at the same time. And it may not be practical to open it with Nano or VI as well. For example, let's say that you have an application that runs 24/7 and it generates a lot of log files. I work with one application like this, and we have about 1.5 gigabyte log file in text every single day. And we have to compress them pretty frequently because otherwise we would run out of storage. But let's say I'm looking for an error message in that file, or I just want to peruse it and see what's been happening. I will not be able to do that with Nano or Cat. If I cat a file, it has millions of lines, it will just scroll through the screen and it will take forever, and I'm not going to get the data that I want. So you will use more and less if you want to page through a file. So let me go to my log directory. Let's see what we got going on in here. Let's find a good lsls, and then R will give me a larger files here in the bottom. And then I can use less, which is the preferred tool of choice, to open up a file such as auth.log.1. Alright, so this goes through all the logins. So now you can see that I have a file in front of me. I can click down and move through the file. I can also press up and move up through the file. It's very handy, right? I can also press space and it will go down by one page, right? So one screen length, it will go down. So this is very, very useful. And when you want to get out, just press Q. Now more is similar to less, however, it actually gives you less, contrary to the name. So if I have more of the same file, I can only essentially hit the space bar and just go down through the file to view it. I cannot go up through the file and press the up key. It doesn't actually do anything. So when you can, use less, but when you can't, use more. It's pretty easy. All right, so the next command is grep. Grep is a fantastic command. It allows you to search for text or regular expressions inside of a file. Now, regular expressions are out of scope for this tutorial, but they're very powerful. I would say it's kind of borderline programming almost. The programmers use them all the time. For example, let's say I have a file with a bunch of phone numbers, right? So all the phone numbers follow the same nomenclature, right? So you have 3 digits, a hyphen, 3 more digits, and then 4 digits. And I know that this is the only format that's used in this file, and the phone numbers are scattered throughout the file, so it would be impossible for me to extract it programmatically simply by parsing it. So what regular expressions allow you to do is they allow you to configure a string that would match certain things. So for example, I can say, give me anything that has 3 digits, followed by a hyphen, followed by 3 more digits, followed by a hyphen, followed by 4 digits. So this is a very simple example, but it's that kind of text extraction that's powerful. That's possible with grep. Very powerful tool, very handy. However, in this lesson, we will only use grep to find a text string. And the text string is very easy. So, for example, let's say that we have this log file that I just showed you. Let's say I only wanted to find items that are from May 5th, right? I can say grep, put this expression in single quotes, auth.log.1. And as you can see, the only text that will be returned by that command, here's my command, everything below that, it has May 5th in it. It's pretty slick. Now notice I have to scroll up and down. It's kind of a pain in the ass, right? Alright, so I'm going to show you something that will make your life tremendously easier. It's called command line piping. So in Linux, there's a couple of things that we can do to redirect the standard output to other things. For example, when I run this command, so when I ran it, it printed the output to the screen. Let me make this window a little bit wider so it looks a little bit better. Still not wide enough. Here we go. So it printed everything to the screen, which is great, but it's not always useful because you may want to do something else with this input. So what I can do is I can, for example, redirect it to a file, and I can use the bigger than sign to send this to a file. So for example, May5 logs.txt. Now when I run lstrh, I can see that I have May5 logs.txt, and if I cat it, I have this content in there. Pretty slick, right? Okay, so now let's get a little bit fancy with this thing. Let's take the output of this command, and instead of sending it to a file, let's send it to another command. So for example, we know that more will take text and page through it, right? So what we can do is we can use the pipe symbol, which is if you hold shift and press the button above the enter key, it's essentially the backslash with a shift. It's called the pipe symbol in Linux. I can send the output of this command output of this command to another command. So for example, less. Now you can see that this command ran. It's right here, and if I scroll down, you will see that I only have one page worth of output in this. Now the command actually ran in the background, and all the output has been generated, but it has been sent to less. So now I can page through it, and here I'm at the end, which is very convenient if you want to parse through a certain string. Now we can also take this and get a little bit fancy with grep. For example, here we're grepping for May 5th, right? Now let's say that there were 10,000 entries for May 5th. We probably don't want to go through all of them. So what we can do is we can take grep and we can pipe its output to grep again. Now this would be a new instance of grep, and this instance of grep would only show me items that happen at 8:17:01. So again, I put this in single quotes. Now note how before, in the previous grep, I would run the command, I would specify the string that I'm looking for, and then I would specify the file that I'm looking for. Since I'm piping output to grep in this example, I don't need to specify a file, and this should do. So I can hit enter, and as you can see now, I'm only getting items that happen at 8 o'clock. It's pretty cool. You can get even fancy with grep. For example, you can use a grep minus v, and grep minus v will exclude entries that meet the criteria. So if I run this now, you can see that I have all the entries except for the ones at 8 o'clock. So all these skills are a little bit of, they're not required if you're a beginner with Linux. However, I wanted to show you the possibilities of a Linux shell, and how powerful it is when you're working with a lot of data. Anyway, I hope you've enjoyed this series on Linux. I know that many people are kind of stuck in the Windows land, but I don't want to have any favorites, but Linux is definitely better in my book.